Section 15.2 Oxidation Numbers. In more complex oxidation-reduction reactions, the identification of the substance oxidized and reduced is not as obvious as the reactions in the previous section. To help identify the atoms or ions that are oxidized or reduced, we assign values called oxidation numbers, or sometimes oxidation states, to the elements of the reactants and the products. It's important to recognize that oxidation numbers do not always represent actual charges, but they do help us identify loss or gains of electrons. Rules for assigning oxidation numbers. The rules for assigning oxidation numbers to the atoms and ions of the reactants and the products are given in Table 15.1. Table 15.1, Rules for assigning oxidation numbers. Number 1. The sum of the oxidation numbers of a molecule is 0, or for a polyatomic ion is equal to its charge. Number 2. The oxidation number of an element, mono or diatomic, is 0. Number 3. The oxidation number of a monoatomic ion is equal to its charge. Number 4. In compounds, the oxidation number of group A, metals, is positive 1. That of group 2 is metals is positive 2. Number 5. In compounds, the oxidation number of fluorine is negative 1. All nonmetals group 7 are negative 1 except when combined with oxygen or fluorine. Number 6. In compounds, the oxidation number of oxygen is negative 2 except in OF2. Number 7. In compounds with nonmetals, the oxidation number of hydrogen is positive 1. In compounds with metals, the oxidation number of hydrogen is negative 1. We can now look at how these rules are used to assign oxidation numbers. For each formula, the oxidation number are written below the symbols of the elements. The oxidation number for bromine is 0 since it's on the periodic table. It's diatomic. For barium, 2+, it's going to be the oxidation number of positive 2. For carbonate, the 2 is oxygen, and there's 2 oxygens, so that's going to be negative 4. Carbonate goes to 0, so the carbon must be positive 4. For the aluminum oxide, the oxygen is negative 2, so there's 3 negative 2s, that's negative 6. And there's 2 aluminums, so 2 aluminums add up to positive 6, so it must be positive 3 each. For the hydrochloric acid, oxygen is negative 2 each, so that's negative 6. The chlorine is negative 1, or the hydrogen is positive 1, so that becomes negative 5, and the chlorine has to balance a negative 5, so the chlorine has to be positive 5. For the sulfate, oxygen is negative 2. There's 4 of them. That gives you negative 8. Negative 8. So negative 8 plus something equals negative 2. So 6 minus 8 is negative 2. And for CH2O, oxygen is negative 2, hydrogen is positive 1 each, and so carbon has to have an oxidation number of 0 in this. Using oxidation numbers to identify oxidation reduction. Oxidation numbers can be used to identify the elements that are oxidized and the elements that are reduced in a reaction. In oxidation, the loss of electrons increases the oxidation number so that it is higher or more positive in the product than in the reactant. In the reduction, the gain of electrons decreases the oxidation number so that it is lower or more negative in the product than in the reaction. An oxidation reaction occurs when there's a charge becomes more positive. A reduction reaction occurs when the charge becomes more negative. Oxidation, more positive, reduction, more negative.